hit record and then share my screen. Can you see? Let's see. Okay, so can you see the notes?
No, not at the moment.
Okay.
Oh, again.
You can now?
Yes.
Okay. Okay, so we're going back to graphing, and what we have are 3 different forms of quadratic equations, and each form tells you something different about the graph. So if you have all 3 forms of the same equation, you can plot those specific points on the graph and make it a lot easier. The first form is standard form, and that kind of goes back to when we first started talking about polynomials. Standard form is highest exponent down. So what it looks like is this: y equals ax squared plus bx plus c, where a is the leading coefficient, b is the linear coefficient, and c is a constant, meaning it doesn't have a variable with it. Now, if the middle term is missing, then b is going to be 0. If the last term, if there's no constant, you can always substitute a 0. But what this shows, if I just look at this equation, I can tell one thing about the graph, and what it shows is the y-intercept. We talked about that before. The y-intercept is whatever that last number is, that c. And like I said, if you had this equation, y equals x squared plus 3x, there's not a constant out here, but you could always put 0, so the y-intercept would be 0. Or if you had this, that 3 is the constant, there's not a linear term, but the 3 is the constant, that's the y-intercept, that's where it crosses the y-axis. So that form of the equation is helpful because it tells you immediately what the y-intercept is. Factored form looks like this. Where that's the one where we look for 2 numbers that multiply to give you the last one and we combine to give you the middle. And whenever we solved it, we found the x-intercepts. So factored form, you can look at those 2 factors for the most part and tell what the x-intercepts are. So you can tell where it crosses the x-axis. One of them is at P and one of them is at Q. Vertex form, we haven't talked about yet, but yesterday we completed the square, and by completing the square, we actually put those equations into vertex form. But vertex form looks like this. Okay, so it shows 2 things. It shows the vertex, hence the name vertex form, and that is at HK. It also shows transformations, and the last page of these notes give the transformations in detail. So transformations are how the graph is changed from the parent function. The parent function is y equals x squared. The parent function is the absolute minimum that it takes to make that graph. And in order to make a quadratic, a parabola, all you need is x squared. So that's why it's the parent function. Any other numbers or parentheses or anything like that added to it changes the way it looks on the graph. And we'll talk about that in a minute. But let's look at this up here. It says converting from standard form to vertex form involves completing the square. Well, when I have 3 blanks, chances are it's supposed to be like this. Completing the square. Okay, so if you look at this one, it says given the following, we have this first form, y equals x plus 2 times x plus 4. This is called factored form. The first question, what information is given by this form? The x-intercepts. The way you find the x-intercepts is you set each one of those factors equal to 0 and solve. So one of the x-intercepts is x equals -2. The other x-intercept is x equals -4. That's where it crosses the x-axis. B says, now convert the equation to standard form and give the new information. Okay, so standard form is what happens when I distribute and combine like terms. So I'm going to start with the factored form, x plus 2 times x plus 4. So x times x is x squared, x times 4 is 4x, 2 times x is 2x, and 2 times 4 is 8. And when I combine those like terms, I get x squared plus 6x plus 8. So this is the standard form. Okay, then it says give the new information. Once it's in standard form, all I have to do is look at the constant here, and that tells me what the y-intercept is. The y-intercept is 8. Now those two are pretty easy. C, it's not difficult. It's just new. So what we're going to do is complete the square. And remember what we talked about yesterday is to complete the square, we're forcing a trinomial to be a perfect square trinomial. A perfect square trinomial looks like this. This is a perfect square trinomial because if I take half of 6 and square it, I get that last number. If I take half the middle number, square it, I get the last number. So 6 divided by 2 is 3, 3 squared is 9. This is a perfect square trinomial, and it could be rewritten like this. So if we look at the one above, y equals x squared plus 6x plus 8, it's not a perfect square trinomial because half of 6 is 2, half of 6 is 3, but 3 squared is not 8. So we need to complete the square. We've got to force it to be a perfect square trinomial. The way we're going to do that, so we have y equals x squared plus 6x plus 8. The first thing I need to do is I need to move that 8 over there. It's plus 8 on the right, so that means it's minus 8 on the left. And now I have this blank here. This blank is for what would make this a perfect square trinomial. The way you figure that out, half of 6 is 3. 3 squared is 9. Now, the one thing is if I add 9 to one side of the equal sign, I have to add 9 to the other side of the equal sign. So over here on the left, -8 plus 9 changes this to y plus 1. And here I'm going to write it, instead of x squared plus 6x plus 9, I'm going to write this as x plus 3 squared. And then to finish putting this in vertex form, I'm going to move that 1 back over. So y equals x plus 3 squared minus 1. Now, the new information is the vertex. The vertex is whatever, the way you figure the x out, it's the opposite of that number. So instead of being +3, it's going to be -3. And it is that number there. So the vertex is -3, -1. Okay. So let's do this again. It's the same questions, but for a different equation. So the first one is, what is this equation in its current form tell you? Well, we could write it down. Right now it's in factored form. And that tells you the x-intercepts. The way you figure that out, x minus 3 equals 0 and x minus 5 equals 0. So one of the x-intercepts is 3. The other x-intercept is 5. B, same directions as example number 1. B says rewrite that in standard form and then tell the new information. So y equals x minus 3 times x minus 5. I'm going to distribute and combine my terms. X times x is x squared. X times negative 5 is negative 5x. Negative 3 times x is negative 3x. And negative 3 times negative 5 is positive 15. Combine those like terms. So standard form looks like this: x squared minus 8x plus 15. Once it's in standard form, all you have to do is look at the constant, and that tells you what the y-intercept is. In standard form, the y-intercept is a constant, so this y-intercept is 15. C says convert now to standard form. Now, one thing is you can't go from factored form, not standard form, vertex form. You can't go from factored form to vertex form. You have to do standard form. It has to be from standard form. So if it gives it to you like this and says convert to vertex form, you first have to distribute combine like terms and then complete the square. So we're going to start right here at y equals x squared minus 8x plus 15. First thing I'm going to do is I'm going to see if this is already a perfect square. Half of 8 is 4. 4 squared is 16, not 15. Since this is 15, then I have to force it to be a perfect square trinomial, which means I got to move that 15 out of the way. It's positive 15 on the right, so it's going to be minus 15 on the left. I'm going to go ahead and skip a space. Now I'm going to force this on the right-hand side to be a perfect square trinomial. Half of 8 is 4. 4 squared is 16. And it's always going to be plus a constant. But remember, if you add 16 to one side of an equal sign, you have to add 16 to the other. And I'm going to simplify this. Negative 15 plus 16 is positive 1. And I'm going to rewrite this as x minus 4 squared. This number is half of that 8, and then it has to have the same sign as that middle term. Now all I have to do is move that 1 back over. This is vertex form right here, and the vertex it's the opposite of that number. The x is the opposite of that number, so it's a positive 4, and then it's the same as that last number, which is negative 1. Okay. All right, so vertex form is where you're going to figure out all of the transformations. Okay, parent function, remember, is the absolute minimum that is necessary in order to declare something a quadratic or linear or something like that. The parent function of a linear, the absolute minimum is y equals x. That's all it takes. Okay, so parent function, minimum requirements. Or a specific function. For it to be quadratic, all you have to do is have x squared and nothing higher than a square. Cubic would be x cubed, x to the 4th, x to the 5th, etc. But we're talking about quadratics, okay? So our transformations, we're gonna, this one doesn't have the last page. Okay, so let me see. We're going to skip example number 3, and I'm going to write down what the vertex form shows, just to save time. Remember, it looks like this: y equals a times x minus h squared plus k. Each one of these numbers, now in order for it to be the parent function, all I have to have is x and the square. So the a represents a transformation, the h represents a transformation, and the k represents a transformation because they're extra above that x and that square. So each one of those represents a different type of transformation. A represents a few things. If A is greater than 0, in other words, if it is positive, so if that first number is positive, the graph opens upward. If A is less than 0, in other words, it's negative, the graph opens downward. Something else A tells you. If the absolute value of A, so not including the sign, is greater than 1, it's narrower than the parent function. If the absolute value of A is less than 1, it's wider than the parent function. So in a minute, I'm going to show you a couple of examples. Okay, H represents a horizontal shift. If H is positive, this represents a left shift of the parabola. If H is negative, it represents a right shift. And then K represents a vertical shift, up or down. So if K is positive, it's upshifted. And if K is negative, it's a downshift. Okay. So let me show you. Okay, so here's an example. We're going to describe the transformation from the parent function. In other words, we're going to describe how it's different. Okay, so this first equation, y equals x plus 4 squared. So the difference here is both of these have an x and a squared, but the one from example 1a has a plus 4. That plus 4 is in the parentheses, so that's h. Remember, h represents a horizontal shift, either to the right or to the left. Since this is positive 4 here, that represents a shift left 4 spaces. That's the only difference in the two functions. And let me show you. Okay, so if I graphed them both on the same coordinate plane, the parent function looks like this. Its vertex is at the origin. It looks just like this. 1a would be shifted 4 spaces to the left. So that's the difference between the parent function, which is in green, and 1a, which is in blue. Okay, B, y equals negative x squared minus 3. So the parent function and 1b, they both have x's, they both have squares, but this one has a negative sign and it has a constant. So both of those things represent something. My suggestion is you work left or right, and everything that's different, you describe what happens. the first thing that happens here is that negative sign. So that means this graph opens downward. And then we have this -3. Since that -3 is not in the parentheses, that represents the vertical shift, either up or down. Since it's -3, that means it shifts down 3. So if I was to draw the two graphs again, the parent function would look like this. This new function here opens downward and it is shifted down 3. So it would look something like that. C, y equals 2 times x minus 2 squared plus 1. This one has a lot going on. Okay, both of them have an x and a square, but this one has a 2 on the outside, a 2 on a -2, and then a +1. So I'm going to work my way left to right. This 2 right here is bigger than 1, so that means this graph is narrower than the parent function. Then the next thing I come in contact with is that -2. It's in parentheses, so that represents a horizontal shift, either right or left. Since that's -2, that means it shifts to the right 2. And then the last thing that I come in contact with is this +1. That's the constant on the far right. That represents a vertical shift, and it shifts up 1 since it's +1. So, oops. Again, here's the parent function. Okay. The new function, it shifts right 2 and up 1, and it's skinnier. And then this last one here, y equals -1/2 times x plus 10 squared minus 3. So first of all, I have this negative sign, which means it opens downward. Then I have this 1/2. That means it's wider than the parent function. And then this +10 in the parentheses means it shifts left 10. And then this -3 means that it shifts down 3. So let me see if I can graph this one over here. So here's my parent function again. This new one, it's wider, opens downward, shift left 10 and down 3, so it might look like this. Any questions?
No. Oh my. I don't know what just happened. No, I don't have any.
Okay. Well, if you do, just give me a holler.
Alrighty.
All right. Well, I'll talk to you later. Thanks, Cade.
Alright, bye.
Bye.